For the first example, example number 1, we have this question. How much heat energy is required to vaporize 12 pounds of H2O at 212 degrees Fahrenheit? Note that at 212 degrees Fahrenheit means 212 degrees Fahrenheit is the starting and ending temperature. Okay, so we're not going to change the temperature, but we're going to vaporize the 12 pounds of H2O. The questions are going to be in this format, and you are going to try and find a starting point. The only thing that will make it easier for you to find a starting point is if you paid attention to where you are starting and ending on the y-axis here, the temperature. All right. In this case, your starting and ending point is 212 degrees Fahrenheit. So obviously, on this graph, you're going to use the distance between point 4 and point 5 because the graph otherwise doesn't have anything that is 212 degrees Fahrenheit. Okay? What does that mean? That means you're going to use this line. And this line itself is representing the from 4 to 5, it represents vaporization of 1 pound of water, and from 5 to 4, it represents the condensation of 1 pound of water. And we do know for 1 pound of water, we need 970 BTUs of latent heat to either vaporize or condense. The question is asking about 12 pounds. Okay, that sounds to me like a straightforward cross multiplication. So if for 1 pound we need 970 BTUs, for 12 pounds we're going to need x BTUs. In this case, x equals to 12 multiplied by 970 divided by 1. And that is going to be, if you multiply it, 11,640 BTUs. That's how many BTUs do you need to take 12 pounds of, in this case, 12 pounds of water from 4 and take it all the way to 0.5, which is 100% steam. So that's the answer to that question. Let's have a look at the next example. Example number 2 is, how much heat energy is required to heat 1 pound of H2O from 70 degrees Fahrenheit to 200 degrees Fahrenheit? Again, the only way for you to get a handle of what you're going to do is to find the starting and ending point. In this case, you are looking at 70 degrees Fahrenheit, which is somewhere here, and 200 degrees Fahrenheit, which is right here. Okay, so those are your points. 70 and 200. All right, so let's see where is the graph. The graph is right here between those 2 points. And what does the graph represent between those 2 points? It represents 1 pound of H2O, which is in this case water. Okay, it's 1 pound of water, exactly what it is. Because 70 degrees H2O is water, and 200 degrees H2O is also water. And we know for a fact from the definition of a BTU that you need for every 1 pound of water, according to the definition of BTU, you need 1 BTU to increase 1 degrees Fahrenheit. Okay, so that's your delta T of 1 degree Fahrenheit. But our delta T is 200 minus 70, which is 130 degrees. So our delta T is 130 degrees Fahrenheit. And that's the difference between 200 and 70 degrees. Those are the starting and ending point of this process. How many BTUs do we need? X. X in this case is equal to 130 BTUs. That's exactly how much heat energy you need to heat 1 pound of H2O from 70 degrees Fahrenheit to 200 degrees Fahrenheit. Our next example number 3 is how much heat energy is required to heat 12 pounds of H2O from 70 degrees to 200 degrees Fahrenheit. Well, in example number 2, we have calculated the same process for 1 pound, and we ended up having 130 BTUs used. Okay, so in example number 3, we need the same heating up water from 70 degrees to 200 degrees, but for 12 pounds. Well, that's going to be easy. The calculation is for 12 pounds, we need X BTUs. And what we're doing here is a cross multiplication where X equals to 12 multiplied by 130 divided by 1. And the answer would be 1,560 BTUs. So that's the answer to this question. Again, example number 2 calculated for 1 pound, and example number 3 here is calculating for 12 pounds. All right. Example number 4 is how much heat energy is removed to cool 12 pounds of H2O from 200 degrees Fahrenheit to 700 degrees Fahrenheit. There are 2 ways to go about this. If you remember, example number 3, which required 1,560 BTUs, was about heating 12 pounds of H2O from 70 degrees Fahrenheit to 200 degrees Fahrenheit. Now, this is asking the opposite. It's asking, cooling. This question is asking about cooling 12 pounds of water from 200 degrees Fahrenheit to 70 degrees Fahrenheit. The matter of the fact is, it doesn't matter in which direction you go. Whether you're going from, say, A to B here, 200 to 70, or 70 to 200, doesn't matter. Whether you go from A to B or B to A, you are still either adding 1,560 BTUs or removing 1,560 BTUs. That is sensible heat, because we have a temperature change that we can sense. Okay, so it doesn't really matter which way you go. You're still moving the same amount of heat. Alternatively, you can simply calculate. If you decide, you can simply calculate. You can say our delta T here is 200 degrees Fahrenheit minus 70 degrees Fahrenheit, which is 130 degrees Fahrenheit. And we know in this range, H2O is water. And we know to cause this much temperature change in water, we need the same amount of BTUs. So for 1 pound, we need 130 BTUs. And for 12 pounds, we need X. In this case, also X is cross multiplication, is 12 times 130, which is 1,560 BTUs. We don't say adding heat is positive 1,560 and removing heat is negative 1. That's not how we do the representation of the amount of heat. We just say 1,560 BTUs. Ultimately, the question is how much heat is being moved either into the material or out of the material. So let's have a look at the next one. And the next one is how much heat energy is removed to cool 1 pound of steam at 230 degrees Fahrenheit to steam at 212 degrees Fahrenheit. All right. You might think this is tricky. It's not necessarily tricky. Again, to decide the starting point, I think that's almost 230 degrees Fahrenheit, right? So we go and see the graph, the point on the graph right here. So this is the starting point. And this, which is 212 degrees Fahrenheit, is the ending point. Now, obviously, there is a temperature change. So we have delta T. When you have delta T, you need sensible heat. So how much heat is removed to cause a delta T of how much? So delta T equals to 230 degrees Fahrenheit minus 212 degrees Fahrenheit. That is 18 degrees Fahrenheit. To cause 18 degrees Fahrenheit change in ice, okay, in steam, in steam, what you need is half a BTU per pound, okay, per degrees Fahrenheit. So you need half a BTU per pound of steam to change 1 degree Fahrenheit. So to change 18 degrees Fahrenheit, you need half of the 18, which is going to be 9 BTUs. So to go from the starting point here, that is 230 degrees Fahrenheit to 212, while it is steam, it didn't condensate, okay? You need 9 BTUs. All right, so that's for question number 5. And for example number 6, how much heat energy is required to melt? How much heat energy is required to melt, okay, 2 pounds of H2O, meaning to go ice to water, obviously, at 32 degrees Fahrenheit. Now, again, at 32 degrees Fahrenheit. So the temperature of H2O doesn't change from the beginning to the end of the process. All right, so we're gonna first of all locate that temperature. It's here. And if we're going to stay at that temperature, there is only one part of the graph that applies, which is 0.2 to 0.3 or 0.3 to 0.2. In either direction, you're using 144 BT moving, not using, moving 144 BTUs per 1 pound. In this case, the question is asking for 2 pounds. So I think it's simple math that says 2 times 144 BTUs, that is 288 BTUs that we need to add to melt 2 pounds of H2O at 32 degrees Fahrenheit. No temperature change. So that makes, if there is no temperature change, that makes this latent heat. All right. Okay, so question number 7. How much heat energy is required to melt 1 pound of H2O at 225 degrees Fahrenheit to 100% water at 32 degrees Fahrenheit? We're going to try and see where those temperatures are. So 25 degrees, let's try and see if we can enlarge this thing here. So we're going to start from 25 degrees Fahrenheit and then heat up the ice, okay? And then go all the way to point 3 where it is literally 100% water, because that's what it says. 100% water at 32 degrees Fahrenheit. I think there are two parts to this calculation. One part is calculating heating up from 25 degrees Fahrenheit to 32 degrees Fahrenheit, okay? And the other part is melting, which is between point 2 and 3. So let's do the first part. From 25 degrees Fahrenheit to 32 degrees Fahrenheit, heating ice, heating up the ice. What does that do? That causes temperature change. So it is sensible heat. And the temperature change is 32 minus 25. That gives you 7 degrees Fahrenheit. And we have said before that ice requires half a BTU per pound per degree Fahrenheit change. So for this we need half of 7, that is 3.5 BTUs. Okay, that is for the first section, which is from 32 to from 25 to 32. And then we have the second section where we are at 32 degrees Fahrenheit and we're adding heat, but we are melting the ice while staying at 32 degrees. We're melting it to 100% water. And we've talked about this time and again, that the melting requires latent heat of 144 BTUs per pound. Okay, so this second part is very simple. It needs 144 BTUs. That's what it is. So the total is 147.5 BTUs. If you apply 147.5 BTUs, you can go from 25 degrees ice to 32 degrees ice and then melt that ice while it is at 32 degrees Fahrenheit. Okay, it's question 7. Let's go to question 8. And example 8, how much heat energy is required to heat 50 pounds of H2O at 25 degrees Fahrenheit to 100% water at 32 degrees Fahrenheit? Well, we calculated that for 1 pound in the previous example. We calculated the amount of heat required to heat 1 pound of H2O at 25 degrees Fahrenheit to 100% water at 32. And it came up to be 147.5 BTUs per pound. This is what we did in the previous question. For this question, we need for 50 pounds, not for 1 pound, okay? Not for 1 pound. So we need X amount of BTU. In this case, the BTUs are going to be X equal to 50 times 147.5 divided by 1, and that gives you 7,375 BTUs. That's how much heat is required in this example. And finally, in example number 9, we are asked how much heat energy is required to heat 50 pounds of H2O at 25 degrees Fahrenheit to H2O at 80 degrees Fahrenheit. All right, so it seems like we're going from 25 to 32. So we're going to go from 25 here to 80, to 80, which is somewhere here. Now, when you are traveling in that direction, you must stop. You must stop at the melting point, or if you pass by 212 degrees, you must stop at the vaporization point. It's a must, because that has its own calculation. So I know the question is asking for 50 pounds. We're going to calculate for 1 pound, okay? And then we're going to multiply the result by 50, okay? So first is going from 25 degrees Fahrenheit to 32 degrees Fahrenheit. In this case, its sensible heat, delta T, is 7 degrees Fahrenheit. We know that H2O is ice in this range, and ice requires half a BTU to increase its temperature by 1 degree Fahrenheit. So to change it by 7, it requires 3.5 BTUs. This is, don't forget, per pound. And then in the second part, we stay at 32 degrees Fahrenheit, and we melt that ice, right? And melting the ice for 1 pound, we need 144 BTUs per pound. In the third stage, let me remove that. In the third stage, you go from 32 degrees Fahrenheit to 80 degrees Fahrenheit. Now, that is also delta T of 48 degrees Fahrenheit. So that's 80 minus 32, that's 48. And I know in this range it is water. H2O is water. And I know for water we need 1 BTU for every 1 degree Fahrenheit change. We know that. So this phase requires 48 BTUs per pound. Okay? And when we add all together, we get 195.5 BTUs per pound. I'm emphasizing that per pound part of it. So that's the calculation for 1 pound. If we want the value for 50 pounds, we multiply that result by 50. And that multiplication will give us 9,775 BTUs. That's the answer to this example. We are going to do more examples, and I will post the videos for the further examples in the following week.